everyone. In this video, we are going to talk about comparing two population proportions. Let's go ahead and get started. First of all, you guys will have to know how to compute what we call point estimates of the corresponding population proportions. Now, you've done that for one sample case, so this should be pretty straightforward. The difference here, we got two. We have P1, which is population proportion 1, and P2, which is population proportion 2. And what we want to do is estimate them based on what we get from two samples independently selected from each population. So they will give you the number of successes and the number of trials for each of the samples. And then P1 hat is the sample proportion, but it also has another name as a point estimate of the corresponding population proportion. And computing just means divide the number of successes by the number of trials for each proportion. All right. Now, this is a large sample test, so it'll have similar assumptions to what we had for one sample. The two samples should be independently selected from each population. And then this is a familiar check that you did, that NP hat 1 minus P hat greater than or equal to 10. But it is now extended to two different samples. I will not ask you to do this, okay? So I feel like I've already asked you for one sample, and redoing the same thing twice is not really going to teach you anything new. So hopefully you still remember how to do it. And we are going to assume in our studies that the assumptions are satisfied and our samples are large enough. Okay, so what we do first is determine the null and alternative hypothesis. So in this section, the null hypothesis will be P1 because this is proportion. So please don't confuse it with mu. This is P, that's proportion. And null hypothesis is the two proportions are the same. Alternative hypothesis is going to depend on the claim. So we'll talk about how do we set it up in a little bit. But remember, it all depends on what's number one, what's number two, and according to the claim, what should be the relationship between the two proportions. Once we figure that out, then we're going to collect the data, use technology to find the test statistic and the p-value, and make our conclusion, which you of course should have this in your already in your notes, and that's true all the time. Okay, so let's look at one example for now. What is the example? So let's look at this. This is a clinical trial of a medication called Nasonex. So when drug companies publish information for the patients about which medication causes what potential side effect, they have to test it out. So as part of their testing, they're going to select two independent random samples. In one sample, they will be given the patients the drug Nasonex, and in the other one, it's going to be placebo, which means that patients do not know what they're receiving, right? So they will always give them something that looks just like real medication, so that we don't have to worry about other potential effects that could influence the response. And then what we're doing is looking at the proportion of headaches in each sample. And so we are wondering if the proportion is statistically significant. Is there a difference between the two proportions? Okay, so let's go ahead and compute the sample proportions first, which is also point estimates. So 547 in the experimental group divided by 2,103. So we got approximately 0.26, which means that about 26% of patients experience headaches while being on Nasonex. Now let's look at what happened in the placebo. So in the placebo group, we had 368 people out of 1,671 had headaches. So that is about 0.22, which is 22%. We do see that there is some difference between the sample proportions, and it does look like the experimental group has larger proportion of headaches. But is the difference statistically significant or not? Well, that's what we need to find out. Now, we want to test here whether the proportion of Nasonex users who experience headaches is greater. Okay, so what does that mean in terms of our alternative hypothesis? Is it going to be a right tail test, left tail test? How do we know? Okay, so what we do is we're going to say, okay, so number one is our group, which is Nasonex. Number two is the control. And what we are wondering if the proportion of headaches in the Nasonex group is greater than that of placebo. So this should be smaller. So when you draw your inequality, always start at the smaller and open it up towards the larger group. And so I think this is going to be a right tail test. And in a second, we're going to also take a look at the test statistic to see if it's positive, because that's what we would expect to happen if this were a right tail test. Okay, so how do we test? So let me show you what to do. You're going to click on the plus sign. You're going to go to inference, which is a familiar menu that we've been using for the past who knows how many lessons. But now you have to decide, is it going to be a t-test menu, which is for the means, or is it going to be a z-test for proportions, which obviously is for proportions? And hopefully everybody understands that we are going to be doing the test for proportions. Now, here we are entering the number of successes first, and it is always less than the number of trials. And then we also, at this time, going to click on this plus, and we're going to enter the same thing for the second sample. So 368 out of 1,671. Let's click on create test. Okay, because we are testing here, we're going to expand the significance test menu. And before we again decide what tail, and I think, as I told you, it's supposed to be right, I just want to confirm what I think is true by looking at the test statistics. So if you look at the test statistic, is it positive? And the answer is yes, it is positive. So it does make sense that it's the right tail option was chosen correctly. Now, all that remains is to figure out what is our conclusion. So that depends on alpha. Alpha here is 0.05. I am going to go ahead and click on the three dots here and export a snapshot of the p-value, because I might need more decimal places than is being displayed over here, just 3. So maybe I need 4. So I would click on that, and it gives me the p-value. So if I need to round it to 4 decimal places, I will just click and say round and then 4. Okay, so that's 0.0023. Is that less than 0.05? Hopefully, you guys know that 0.0023 is actually less than 0.05. But if you don't know or just want to check, you can always subtract them. And because the answer is negative, that means that it is statistically significant result. And we are going to reject the null hypothesis. And we will say we have enough evidence to conclude that the Nasonex group has more headaches as compared to placebo. Now, there is one last thing that I wanted to mention, and that is the difference between statistical significance and practical significance. And there is such a difference. Statistical significance means that, as you can see, we conducted a test and the difference was statistically significant. We would say, yes, there are more headaches for people who are taking Nasonex. However, practically significant, whether that is the case or not, will it stop a patient who really needs the medication that controls the symptoms from taking the medication? So personally, if I see a difference between 0.26 and 0.22, so about 4% more people in the sample experience headaches, to me, that probably wouldn't be important enough to not take the medication.